This is lesson 3.4, which deals with applications of right triangles, and this is the last lesson for chapter 3. Now, when dealing with applications of right triangles, the first thing we need to talk about is angles of depression and elevation, which is typically what we look at with right angles and applications of these. So, this is pretty straightforward. An angle of depression, if we take the horizontal and then we look down, essentially. So if you think of someone standing here and looking down, the angle of depression, theta, would be based on the horizontal looking out and then looking down. The angle of elevation, similarly, is if we have the horizontal but instead we look up. And that will give us our angle of elevation. So, suppose that we have a mine shaft that extends down with an angle of depression of 5 degrees, so a very shallow angle. How long will the shaft have to be to reach a vein of coal which is 65 feet directly below the surface? Anytime we are dealing with applications and triangles, the first thing we want to do is draw a picture. So in this case, we have our horizontal. Since we have an angle of depression, and again it's a very shallow one of 5 degrees, then we're going to be looking down, and we have this vein of coal which says is 65 feet directly below the surface. So 65 is going to be our vertical piece here, and our right angle is going to be formed between the horizontal and the vertical pieces. So the only thing that it is asking for in this case, think for a second, which side of the triangle is it asking for? It's asking for the hypotenuse here, C, because it wants to know how long the shaft will have to be to reach this vein of coal. So in this case, if we want to find C, we only have to do one calculation, and in this case, with the given information, we've got an opposite side and we want to find the hypotenuse. So opposite and hypotenuse tell us we need the sine of 5 degrees is equal to the opposite, which is 65, divided by C, which is the hypotenuse. And as we noticed in the last video, in this case, since C is in the denominator, we need to do a couple extra steps. We're going to multiply both sides by C, and then we end up with C times the sine of 5 degrees is 65, and then we need to divide by that sine of 5 degrees, and we end up with C being equal to 65 divided by the sine of 5 degrees, which is approximately 745.8 feet. So this is a rather long shaft, and that has to do with the fact that the angle is so small. So this is our answer here. This is how long that the shaft would have to be in order to reach this vein of coal. The next example says a railroad track has an angle of elevation of 1 degree. So since this is an angle of elevation, we are going to draw this up. It should technically be smaller than the previous drawing, but it's really hard to see 1 degree. It is very minute. Again, our right angle is going to be here between the vertical and horizontal. They want to find what the difference in altitudes of 2 points on a track that are 1 mile apart. So this one might throw you for a second. What they're saying here is that the track, which is actually the hypotenuse, this is the part that the train is going to be running on, this is 1 mile apart. And we want to find the change in elevation. So I'm going to call this A. In this case, we are given, again, we got an angle, we've got an opposite side and a hypotenuse. So we're going to use sine again because we have the opposite and the hypotenuse. So sine of 1 degree is equal to the opposite, which is A, over the hypotenuse, which is 1. So in this case, all we have to do is multiply both sides by 1, and we end up with A being approximately 0.01745. And I wrote this many decimal places because we're talking about miles here. And it's a lot more helpful if we can convert this to feet. So just a real quick lesson, there are 5,280 feet in 1 mile. And so we can do this conversion by multiplying by 5,280. And if we do so, we end up with A being approximately 92.1 feet. And that's a little bit more reasonable to understand than 0.01745 miles. So this was part A of the problem. I want you to pause the video and complete part B, which asks what happens if instead of 1 mile apart on the track, we have 2 kilometers apart on the track. So for this example, you should have found that B was approximately 0.0349 kilometers, which comes out to be, if you move this decimal place, if you know metric, you can move it 3 decimal places to get 34.9 meters. We have a few more examples here to work through. Now with these next few examples, again, we're going to be using the angle of elevation and depression. So example 33 says we have a horizontal distance of 175 feet. It's measured from the base of a vertical cliff. The angle of elevation from this distance is measured to be 74 degrees. We want to find the height of the cliff. So I want you to pause the video and try this example, then resume to find the correct answer. You should have drawn the picture with the angle of elevation as 74 degrees, and again it tells you that horizontal distance from the base is 175 feet. We want to find the height of this cliff. So in this case we have the opposite. We want to find the opposite, and we're given the adjacent, and so we're going to use tangent in that case. So tangent of 74 degrees is A over 175. Multiply both sides by 175, and we get that the height of this cliff is 610.3 feet. Now this next example is a little bit more involved because it's going to require 2 triangles. If you notice, there's 2 angles given. In this case, suppose Carla is piloting a helicopter in the wilderness at 1,200 feet above the ground, searching for a downed plane. As Carla spots it, she measures its angle of depression as 53 degrees. She also spots a road directly in front of this whose angle of depression is 15 degrees. So we want to find the distance of the downed plane to the road so she can tell the rescue how long it's going to take for them to find the downed plane from this certain position. So if we have our helicopter here and she is looking out, again this is an angle of depression, so we're going to draw that horizontal up at the top. We have an angle of depression of 53 degrees. And we said that her height up is 1,200 feet. Now, if we look at the road, on the other hand, so she's looking over here at a road, and in this case, I'm going to draw this with a different color. This was at an angle of depression of 15 degrees. Again, if we draw our height up, we end up with 1,200 feet. Now, if you notice here, we want to find the different distance between the plane and the road. We're going to call that D. And so if we find the bases, or the tops, if you will, for these 2 right triangles and subtract them, we can find the distance that we need. So in this case, let's look at the blue triangle first. That tells us that we have an opposite side, and we want to find the adjacent side, so we want to use tangent. So we have tangent of 53 degrees is equal to our opposite, which is 1,200, divided by our adjacent, we'll call it A. And in this case, if we multiply both sides by A, we get A times the tangent of 53 degrees is equal to 1,200. And then we need to divide by that tangent of 53 degrees. And we get that A is going to be 1200 divided by the tangent of 53 degrees, which is approximately 904.3 feet. So there's our distance A. I want you to pause the video now and find the entire distance. Keep in mind this is going to be the entire distance B of this larger red right triangle. So in this case, you should have found that B was approximately 4,478.5 feet. So then to find D, which is our final step, we are going to subtract the two. So 4478.5 minus 904.3 is going to give us a grand total of 3,574.2 feet. And so this is the distance she should tell them to find the down plane from the position on the road that she has spotted. So we have one final example here, and it deals with electronics. AC, or alternating current circuit, the relationship between the impedance Z and the resistance R, and the phase angle is shown by the right triangle I have drawn. Suppose you are told that the resistance is 94 ohms, and that symbol there is an omega, Greek letter omega, means ohms, and the phase angle is 36 degrees. If you want to find the impedance, which trig ratio would you use and find it? So in this case, we want to find Z. We are given the adjacent side. We want to find the hypotenuse, so that tells us we are going to use the cosine of phi. So we have cosine of 36 degrees is equal to the adjacent, which is 94, divided by the hypotenuse Z. So in this case, we need to multiply both sides by Z. We end up with Z times the cosine of 36 degrees equals 94. And then we need to divide both sides by the cosine of 36 degrees. And we end up with Z is going to be 94 divided by the cosine of 36 degrees, which comes out to approximately 116.2, and in this case, ohms. I'm going to keep the same unit that we had. So I want you to pause the video and complete this last part B and check your answer when you're done. For this example, they were actually asking for the phase angle. If you wanted to redraw the triangle down below with the given information, the resistance was 250, the impedance was 400 ohms. So again, we're going to set up that cosine of phi is equal to, in this case, 250 divided by 400. To find the angle, again, we need the inverse trig function of cosine inverse, and we end up with a phase angle of about 51.32 degrees. So this concludes the video for section 3.4, which talked about applications of right triangles. Please go online now and complete your homework for this section, and then complete the quiz for chapter 3.